Hi everyone, welcome to part 2 of my design pattern factory method tutorial. And in the previous video we discussed the simple factory method. In this video we'll take a look at the UML diagram and actually implement the factory method pattern with abstractions. So let's get started. So since we have looked at it already and we know that factory pattern provides an interface which encapsulates object creation and lets the subclasses decide what object to create. Let's quickly go to the UML diagram and try to visualize this. So this is the UML diagram for the factory pattern. So here, as you can see, that we have a creator, which is an abstraction, which is provided to the client. So this client will have an instance of this creator and will actually depend on an abstraction of this creator. The client won't know the actual implementation of the creation logic. So this creator will probably be an interface which will be implemented by this concrete creator, which will actually be instantiating the concrete object, which is actually a subclass of this product abstract class. So now let's quickly jump into that code. We'll be starting where we left off in the previous video. We will refactor our simple factory method and we'll remodel our code to use this factory pattern and to use this abstraction logic. Alright, so this is the place where we left our last video. In the last video, we created a simple factory class which has a create animal method which was creating an instance of the animal subclass based on the subtype provided. Even though we have encapsulated the creation logic, we still have not abstracted it out. So let's quickly go to the pet store class. Alright, so here, although the creation of the animal subclass is encapsulated, it is still not abstracted out, which means that this pet store still has a direct dependency on this create animal method, which means that this code is still very tightly coupled to this create animal method in this animal factory. So now let's code it to abstraction. So let's quickly go ahead in this animal factory method and remove all this creational logic from here and also make this an interface which returns an animal instance, and let's also remove the unused imports. Now I have already created one class which I have named pet store factory, which will be implementing animal factory. So let's quickly go ahead and implement these methods. Okay, so here in this animal factory we will just paste our code what we copied from our actual simple factory method. So now instead of calling the animal factory directly, this pet store will have an instance of animal factory object, but it will be pointing to an abstraction of the factory object. Also, we will be providing a constructor for pet store which will be taking a animal factory object and it will set the animal factory object in the pet store class. So let's quickly go ahead and instantiate the pet store class with a factory object injected through the constructor. Now let's replace the simple factory call with the abstracted call. Now let's try to run this method and observe the output. So as you can see, everything is working fine. So let's go ahead and discuss what's happening here right now. So in the definition, we already learned that this factory pattern encapsulates the object creation by providing an interface and lets the subclasses decide what object to create. So let's try to make our code relate to the UML diagram so it will make the concept more understandable. So we have our code and we have our UML diagram. In this UML diagram, we have one creator which is an abstract. So first of all, in the UML diagram, we have a client which is represented by this box, and this client has an instance of a abstract creator. So let's go ahead in the code and try to figure out who is our client. So this pet store class is our client, and in this pet store class there is a factory interface which it is holding a reference to. Now in this UML diagram there is a concrete implementation for this factory interface which is represented by this box which is called concrete creator. Similarly, in our code also we have a concrete implementation of the abstract factory which we have defined here and which is providing the actual implementation of the creation logic. So let's again go into the pet store class and have a look at the definition once, it says that the interface encapsulates the object creation and lets the subclass decide what objects to create. So, similarly, here, this interface is encapsulating the object creation as well as abstracting it out. And comparing to the simple method factory pattern, the direct dependency is gone now. So, if you remember, in the simple factory method pattern, if you went inside the create animal method of this factory class, you were actually able to see the implement details of that creational logic. But now, since we have abstracted out the factory itself, if we go inside the create animal method, we will find nothing. This means the pet store does not know any implementation details of the animal creation. It is just delegating the responsibility to the factory object and factory object doing all the logic, and this factory interface is delegating the responsibility of creation of the animal class to one of its subclass. And the way we are instantiating this factory reference is by injecting a implementation of this animal factory, which is nothing but our pet store factory. So when you call factory.createAnimal, the call actually goes to the subclass of the animal factory, which is providing all the creational logic. So now the advantage with this approach is that our code is not tightly coupled and dependent on the creational logic. In future, if any change is required in the creational logic, our pet store class is completely independent of all the changes which is required in the creation of the animal. So by implementing this factory pattern, we have put the dependency of this creational logic in this pet store class. And one important point to be noted is that if in future we don't want to depend on this pet store factory method and we want to depend on some completely different factory, all we need to do is to just create a new implementation for this animal factory interface and inject it via constructor of the pet store class. The benefit of using factory pattern is that this factory can have any number of implementing subclasses, and since the pet store is not depending on any of the implementation details in this factory, it can actually take any implementation of this factory and there will be no change in the pet store class and the code will just work fine as long as the factory is returning an object which is a subclass of an animal. Alright, let's talk about the benefits of using this pattern. The first benefit is it follows the single responsibility principle. Your methods will be smaller and every method will have only one responsibility, which will make it very easy to test your code. The second benefit is it follows the open-closed principle. That means your classes are open for extension but closed for modification. As you already saw that even if you change this instance of the implementing factory, no code change is required in the pet store class. The third benefit is that it also follows the dependency inversion principle. As I explained, the pet store class is not depending on the implementation details in the create animal method of the factory. But this was not there with the simple factory method. In the simple factory method, the code was still encapsulated but not abstracted out. It means in the simple factory method, the main disadvantage what I feel is that even though the code is encapsulated, it's still not abstracted out. It means the pet store class is still depending on the create animal method in some way, and it knows the implementation in the create animal method. So if the create animal method changes sometime, it will indirectly impact the pet store class. The fourth advantage is all the creational logic is abstracted out and put it in a single place. So now your code base will not be cluttered with all this creation logic, and every time you need to make a change to the creation logic, you will always come to this factory class and make the change here. So I hope that you have learned all the concepts which I tried to teach you in this video. If you have any doubts or suggestions, feel free to comment below and I will try to answer that out. So wrapping this video now, in the next module, we'll be comparing the simple factory and the factory pattern. We'll compare them and we'll also try to see when to use what pattern, and we'll go through some of the real world examples where this factory pattern is actually being used, and I'll try to make you more familiar with this factory pattern and so you don't hesitate to apply it. Also, we'll look at how to identify the code smells which you should look for that will give you a hint that a factory could be a better approach. So thanks for watching my video and I'll see you in the next one.